STEM science.
Okay, here is the next type of charging method. Again, this is the second type of charging through contact through the use of something called conduction. So this is not the same thing as friction. This is simply charging by contact through conduction. So what does that mean, conduction? Well, it's actually just when we bring two objects together and the charges will literally move, the negative charges will move from one object to the other object. No friction required. All right, but there are some key differences here. Now, the first thing I want you to see here is that this object, we're going to start with a negatively charged object, and you can see why it's a negatively charged object. You got more negative charges in comparison to the positive charges on here. So because there are more negative charges compared to positive charges in this object, this is a negatively charged object. This one here, same number of negative charges compared to positive charges, this is a neutral object. So this is another reminder that when you're drawing these, be really mindful and deliberate about how many negative charges you're putting in there versus positive charges, because if you're not careful and you start sort of putting the inappropriate numbers of charges that make it look like it's neutral when in fact you want it to be negative, that's something that you're going to have to be really careful with, because I'm going to read into this and assume that if you're just drawing this object here, I'm going to read this as neutral. So if you're not careful, or if you put an extra negative charge in here and you want this to be like a neutral object, I'm going to read it as a negatively charged object. So just be mindful that you're careful about how many negatives and positives you're putting into your objects if you want to sort of indicate that it's negative or positively charged or neutral. So anyway, we've got a negatively charged object here, we've got a neutral object here, and what we're going to do is we're going to basically charge this object through contact, or what we call conduction. And I'm just going to move this to the middle so it's a little bit more centered there. All right, and we're going to do it. So let's take this negatively charged object and we're going to sort of drop it down onto it like that. And contact is made. Conduction can occur. This is not friction. We're not rubbing this object. We're basically going to allow the charges from one object to flow to the other object. Now, this only happens with certain types of materials that would allow for charges to simply move. So chances are something like a metal is really good at conducting charges. So this is probably, if this is where the charges are going to move to or from, this is probably one of these things has to be probably a metal. Now, where are the charges going to move from? So again, let's just consider this. This is only going to, again, allow for negative charges to move. The positive charges do not move. The negative charges, which are based because of electrons, are the only ones that are going to be allowed to sort of move between these objects. And if we have one here that has an excess of electrons and one here that has basically equal numbers of electrons to protons, or negative charges to positive charges, this is the one that's going to do the movement of electrons to the neutral object. And it kind of makes sense when you think of it, because basically what you're doing here is you've got an excess of electrons and just the right number of electrons here. These electrons are really going to be sort of more attracted to the more sort of neutral object. They're going to want to get off this thing. Well, how many are actually going to get off? This is where we sort of split the difference. And if we were actually being really picky here, you could see that we've got sort of 10 negative charges here compared to the 6 here. So we've got, let's say, an abundance of 4 extra negative charges on this negatively charged object. So if we really want to be precise in here, we would say that this negatively charged object is probably going to just transfer over just enough negative charges, and I know they're sort of tilted here, but just bear with me. These are still negative charges. It's going to donate over enough negative charges so that it balances out the charge between the two objects. And if you look carefully at the charges here, we've got now sort of 8 negative charges here, and we've got 8 negative charges here. We still only have 6 positive charges and 6 positive charges here. So ultimately what we have are 2 negatively charged objects now. Whereas when we first started this, we had 1 negatively charged object and 1 neutral object. Now we have 2 negatively charged objects. And that is what we mean by charging by contact through something called conduction. Take a look at charging by contact through conduction. Again, the same idea, except let's take a look at it from the use of a positively charged object and a neutral object. So similar to the other one, this is a positively charged object. You can see that we've got here a change, difference there of negative charges to positive charges. We certainly have a deficiency, let's say, in the amount of negative charges. So as a result, this is positively charged and this is neutral. And what we're going to do is we're going to, again, bring this into contact with the object there, and there it goes. Contact is made. Conduction, because the material, let's say again one of these things being a metal, so conduction is allowed to take place where charges are allowed to sort of move between the two objects. Now, unlike the one that we had before where this was a negatively charged object, this way, again, I want to make sure you understand that only the negative charges can move. And in this particular case, because this is deficient or really lacking in the number of negative charges in this positively charged object, what's going to happen is that the negative charges from the neutral object will actually move into the positively charged object. So in fact, the neutral object is going to supply the electrons to the positively charged object. And how many electrons is it, or how many negative charges is it going to donate? It's going to donate enough so that both objects are left with, oops, let me just get rid of that there, sorry, are left with the same number of negative charges. So let me just push this back a little bit here because I think that's what's going on. All right, so it's going to donate 1, maybe 2, and at this point you can see that the number of negative charges between the two objects here are basically the same. You've got 4 negative charges here and 4 negative charges there, so it's going to be basically where it stops. So let's take a look and see what we've got now. Alright, so this object here has lost 2 negative charges, so as a result, this is now, when you look at the number of positive charges to negative charges in this object here, it is no longer neutral, it is now a positively charged object. Here you can see that this is still deficient as well. This still only has 4 negative charges compared to the 6 positive charges. So this is now positively charged. So what I want you to see here is that we have a number of different scenarios. We have one scenario where we have this, which was our first example, a negative charge coming into contact with a neutral object, and what you end up having is a exchange or transfer of negative charges, and it's basically split from between the two objects, and now both objects leave as being both negative. And the other example that you can see here is we've got the positively charged object coming into contact with this neutral object, and again, contact is made, conduction is able to take place, and you have the transfer of negative charges. And in this case, it's the negative charges from the neutral object being transferred partially to the positively charged object, but what you end up having here is 2 positively charged objects. So that's basically charging by contact through conduction. And notice the pattern here. You need one charged object, whether it's negative or positive, and coming into contact with a neutral object, and at the end of it you end up having 2 charged objects both having the same charge, both positive in this case, and in the other example we had the negatively charged object coming in contact with the neutral object. An exchange of negative charges took place, this time from the negatively charged object to the neutral object, and you both end up with 2 negatively charged objects. Alright, there it is.